Hi guys, this is a video for the Quiz 3-2. This will be the key for the quiz you took. I did put the grades and as much comments and feedback as I could on Google Classroom. If you have any questions beyond that, the comments, and this, the key, please let me know. Email me or send me a chat. Be happy to do a Google Meet or email you back, whatever works. So here we go. Lexi is playing with a standard deck of 52 cards. She shuffles the deck thoroughly and then deals the cards. So that assumes that we have randomness, and each pick will be random or each draw will be random of a previous draw. So let's go. A, what is the probability the first card she deals will be an ace or a king? Keyword there is or. So the first thing that I think of when I see or is that it's going to increase the probability if I can choose if one or the other can happen. So if I have several possible outcomes, I'm thinking of a greater probability of those happening. So this is going to be an addition problem. When we add two positive numbers, we get a larger positive number. So let's see, the probability that the first card she deals will be an ace is 4 out of 52. There's 4 aces in the deck, and there's 52 total cards. And I'm going to add to that the probability that the first draw is a king. So that's another 450 seconds. And of course, we have to know how to add fractions. Hopefully that's prerequisite knowledge, but 450 seconds and another 450 seconds is 850 seconds. This could obviously be reduced as well. If we divide 8 and 52 by 4, we could call that 2/13. So both of these make sense intuitively. There are 4 aces, there are 4 kings. Those are independent of each other. You can't have an ace and a king at the same time. So we simply add those, and there's 8 cards out of the full deck of 52 that we could possibly choose and meet the criteria of it being an ace or a king. 2/13 also might make sense to you as well if you consider that 13 is 1/4 of the deck of cards, and that might represent a suit since there are 4 suits. And out of an entire suit, which would be 13 cards, 2 of those are represented as an ace and king. So 2 out of 13 makes intuitive sense as well. Okay, let's go on to the next one. What's the probability that the first 2 cards she deals will be kings? Okay, so this one's a little different than an or probability. Now I'm thinking it's got to be a king and then another king. So that's going to reduce the probability of just one king. So just one king is 4 out of 52. But now this other thing has to happen additionally. It's got to be another king. So really what we have here is the probability of a king and another king. So with an and probability, we need to multiply. With a compound probability that involves and, we need to multiply the 2 probabilities. But there is a little trick here. This is a conditional probability in which drawing one king creates a different probability for the next draw. So 2 things are happening. We have 1 less king, so we only have 3 kings for the next draw, and we actually have 1 less card in the deck. So the probability of getting a second king, given that you've already drawn 1 king, is 3 out of 51. So there's a lot to think about on this one. So when you multiply 450 seconds and 350 firsts, that comes out to 2650 seconds. Now you could have reduced the 450 seconds first and then done the multiplication. This would be an acceptable answer, but it does reduce nicely to 1 out of 121. 12 goes into 2652 121 times. As a decimal, this is 0.0045. Okay, next one. What is the probability the first card she deals will be a king or a heart? So once again, you see the word or, you're thinking a greater probability of a king or a heart. However, these are not independent events. In other words, they're not mutually exclusive events. So it is possible to get a king and a heart simultaneously. So think of that overlap in the Venn diagram. This section here represents the king of hearts. And that's only one card. So in this case, we're going to do our probability of a king for 50 seconds. This is just one draw, first card she deals. Or, so I'm going to add the probability that could be a heart. There's 13 hearts in the deck, 1/4 of the 52. Except if I add the 4 and the 13 now, and I'll actually do that, I've counted the king of hearts with the kings in that 4, and I've counted the king of hearts with the hearts, that 13. So I do have to subtract the probability of a king and a heart, and that's your 16 out of 52. You could reduce that and put it in decimal form as well. There's the 3 answers for 1, A, B, and C. All right, let's move on to Yahtzee. Okay, so there's the first rule for Aurora. She's thinking about what to do, and she's feeling like a large straight would be a good option. She still has that box open on her card. So she's going to pick up one of the 5s. So she's looking at a 2, 3, 4, 5. Well, a large straight is 5 consecutive integers. So we actually have 2 choices here. And this is a good move for Aurora to go for the large straight. This is the best chance to go for the large straight when you're sitting on a 2, 3, 4, 5, because you could get a 1 or a 6. 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. So the probability of getting a 1 is 1/6, or the probability of getting a 6, which is 1/6. So we're going to add those probabilities and get 2/6, or 1/3. She has a 1/3 probability of hitting that large straight. All right. Well, she could do other things, obviously. What's the probability that she's going to go for Yahtzee? So she's going to pick up the 2, 3, 4. Well, that obviously makes the most sense if you're going to go for Yahtzee. Pick up the 2, 3, 4. So she's got to get a 5 and a 5 and a 5. So she's got to get the probability of a 5 and a 5 and a 5 is the product of those 3. 1/6 to the 3rd power is 1 2/16. It's unlikely, but not terribly unlikely. And you could have called this 0.0046. Okay, the first bonus. Many of you got very close to this. You forgot that one thing here, and I'll show you in a second. What's the probability of actually rolling a Yahtzee on the very first rule? Well, this would be similar to the problem I just did, except we haven't rolled any dice. We have nothing sitting on the table. So we actually have to get all 5 dice to be exactly the same. But recall that from the problem I just did, we were going for a specific number, 5s. We had to get 3 5s. But with Yahtzee, you could get 5 5s, you get 5 6s, 5 4s, 3s, 2s, or 1s. There's actually 6 ways to get Yahtzee. So I have to take 1/6 to the 5th power, but then I have to multiply that by the 6 options, or the 6 different ways there are to do that. So if you said 1/77776, you were very close. Multiply that by 6, which is 6/7776, which translates to 0.000772. Next. Okay, so we have a contingency table here. It's a great way to visualize conditional probabilities. We have two different sales approaches happening. We have the aggressive approach and the passive approach, and we have the recorded number of sales with both types of approaches. So you want to total up these columns and rows, and you can see that there were 1,160 customers sampled here, so pretty large sample. We can get some good information from this. So what's the probability of randomly selecting one of these customers? Or another way to think of it is, what is the percentage of customers who a sale was made to? So we get that piece of information first. So probability of a sale is simply this column total out of the total customers in which we kept track of. So 686 out of 1160. Pretty straightforward on that one. You could have converted this to the decimal value, which is 0.591, which might be a better way to present this to your boss or whoever was doing this research, the board of directors. Or we might even say that 59.1% of the customers we made a sale to, or a sale was made to 59.1% of the customers. All right, if one of the 1,160 customers is randomly selected, find the probability of getting a customer that was a sale and the passive approach was used. Well, this one is pretty straightforward with the table. Without the table, it would be definitely more complex. So we're looking for the customers that were both a sale, so the sale column, and the passive approach was used, so the passive approach row. And you can see clearly now that the 416, whoops, that is not the highlighter. That is not the highlighter. Let's try that again. The 416 is the intersection of those two conditions. We had a sale and the passive approach was used. So 416 is the number, and the total possible customers is 1,160. So 416 out of 1160, or 0.359. And the last one on this part is, if one of the 1,160 customers randomly selected, find the probability of getting a customer that was a sale or the aggressive approach was used. Okay, we need a sale or the aggressive approach. Let's get rid of this now. Okay, the probability of getting a sale would be 686 out of 1160. Or we could select someone where the aggressive approach was used. That's 580 out of 1160. So we'll add those two probabilities. Do you see the problem? Hopefully you do. There are some that we've counted twice. There are some customers where both the aggressive approach was used and we got the sale. So here we have to subtract the fact that we counted them twice. So we subtract one set of those people. That's 270 out of 1160. If you wanted to save some time, you could not write these large denominators and just remember that in the end it'll be out of 1160, and simply add 686 and 580 and then subtract 270. And that would be 996 out of 1160, or 0.859. Hopefully you'd recognize, if you forgot to do the subtraction, you hopefully would recognize here that 686 and 580 is greater than 1160, and you would get a probability that is greater than 1, which, as we know, is impossible. Let's wrap this up with the bonus. What's the probability of a sale given that the passive approach was used? So this is a conditional probability. Given the passive approach was used, well, that brings us down to a smaller number of customers. So given the passive approach was used, we're only talking about 580 customers now. Those were the only ones in which the passive approach was used. Of those 580, how many were a sale? And in this case, it's 416. So given the passive approach was used, what's the probability of a sale? This is important information because it says, if you use the passive approach, how likely are you to generate a sale? And it's pretty likely in this case. This is 416 out of 580, or 0.717, or about 72% of the time, if you use the passive approach, you'll get a sale out of this 1,160 customer sample. Just for fun, let's do the probability of getting a sale given the aggressive approach was used. That's 270 out of 580. And 270 out of 580, let me calculate that for you. I haven't done that before now, is 47%, 0.47. So in this case, it appears that the passive approach is more effective. Okay, hopefully that helps clear up any misunderstandings that you had when you took the quiz. Again, if you're still not clear on anything, let me know. Have a good day, guys.